Welcome to the lesson on what is lean. Upon completion of this lesson, learners will be able to define lean manufacturing principles, trace its historical development from Toyota's production system, distinguish lean from traditional manufacturing methods through key characteristics and practices, and demonstrate understanding of critical lean concepts, including non-value added activities, takt time, cycle time, lead time, process flow optimization, and one-piece flow implementation. Lean is a continuous improvement process that refers to minimizing waste and maximizing value while using fewer resources. Lean is a philosophy that has company-wide effects, from production technicians to high-level management. For this reason, making the transformation to lean is sometimes referred to as a change of culture. Lean manufacturing is a process improvement system with four key interrelated focuses: eliminate waste, improve process flow, create a higher level of efficiency, and improve quality. Lean manufacturing principles help companies improve their processes and management methods and have many benefits, including minimizing unnecessary costs, reducing waste, and enhancing inefficient procedures and bottlenecks. Lean manufacturing is a way to slash the sources of waste while still upholding customer satisfaction. Simply, the goal is to streamline the production process by eliminating all non-value added activities. Non-value added is a description used for any activity that does not add to the product quality, where the customer defines quality. On average, over 90% of manufacturing time is spent on non-value added steps. This means that only between 5 to 10% of a product's manufacturing life is spent on activities that actually add value to the product. Bottlenecks are common in traditional manufacturing processes, where the lean process should flow like water. Lean manufacturing uses several building blocks that help identify and eliminate the many sources of waste. There are several stories about where the inspiration for lean came from, but popular belief is that it was sparked in an American grocery store. The practice of restocking shelves only after items were removed urged automobile industries to believe they could do the same. In the 1920s, although a patron of traditional manufacturing, Henry Ford was one of the first to recognize lean thinking and integrate it into manufacturing. Although Ford's production method differed greatly from the lean methods used today, he identified and implemented a few factors that make up modern lean practices. Ford suggested that the price of cars could remain low by shortening the production cycle. Ford also practiced the concept of moving parts through an assembly based on the sequence of the process and believed in eliminating non-value added actions. Today's lean principles come from the Toyota production system, also called TPS. In the 1930s, Kiichiro Toyota of Toyota Motor Company developed the idea of just-in-time production, also known as JET, which is a key concept in lean. It wasn't until the 1950s that Taiichi Ohno was able to put the ideas into practice. Taiichi Ohno took the ideas developed by Kiichiro Toyota and created a plan to put them to work using tools like Kanban, a scheduling system using cards, signs, or software to display specifications and instructions related to production. Lean principles may not seem like a revolutionary method to us, but it transformed the mindset of manufacturing. Companies that had previously been devoted to mass production were now introduced to new ideas that challenged their practices. Before any lean tools and techniques can be used, the basics of lean must first be understood. One reason lean has been so successful in manufacturing is the consideration given to all levels, departments, and individuals within the company. Lean emphasizes the importance of everyone from upper-level management to technicians and operators on the production floor. For this reason, lean is most successful when cross-functional teams are created. Often, a specific project team is formed to complete a lean project. We will now explore the basic differences between traditional and lean manufacturing approaches. Traditional manufacturing, typically employed by mass-producing companies, operates on a push production system where inventory is considered an asset and production occurs in large batches. This method relies on specialized machines designed to produce identical parts in high volumes. In contrast, lean manufacturing, which was pioneered by Toyota, takes a fundamentally different approach. It employs a pull production system, viewing inventory as waste to be minimized. Lean manufacturing emphasizes small batch sizes and one-piece flow, utilizing multi-purpose machines that can produce a variety of parts rather than being limited to a single type. The differences between traditional and lean manufacturing extend to workforce management and facility organization. In traditional manufacturing, workers are kept constantly busy regardless of customer demand, and they typically specialize in a single area of expertise. This approach relies heavily on production forecasts and scheduling to determine output levels. The facility layout in traditional manufacturing is organized into departments that group machines by function. In contrast, lean manufacturing takes a more dynamic approach, where worker activity is directly tied to customer demand. Workers are multi-skilled and capable of performing multiple operations, allowing for greater flexibility. Production decisions are based purely on actual customer demand rather than forecasts. The facility layout in lean manufacturing follows the sequential flow of products through the process, rather than being organized by department functions. This creates a more streamlined and efficient production flow. The quality control and operational philosophies also differ significantly between traditional and lean manufacturing approaches. Traditional manufacturing relies on final product inspection to catch defects, whereas lean manufacturing builds quality checks into every step of the process, continuously monitoring and eliminating defects. The traditional approach follows a just-in-case mindset, while lean manufacturing operates on a just-in-time basis. There's also a stark contrast in responsibility distribution. Traditional manufacturing places responsibility primarily with management, while lean manufacturing empowers employees with direct responsibility for their work. Perhaps most notably, traditional manufacturing aims for merely acceptable performance standards, while lean manufacturing strives for perfection in all aspects of production. Let us now analyze the key concepts of lean. In most industrial processes, and particularly in lean manufacturing, there are many different time metrics that might be of interest to the project team. Often, time metrics and measurements are used interchangeably, even when they mean very different things. It's important for anyone involved in a lean project or in production to understand the differences in time values. There are a few different time metrics used in lean, like takt time, cycle time, and lead time. We will discuss each time metric in detail in the upcoming slides. Takt, in German, refers to the beat kept by a metronome for musicians. It is the amount of time available to produce one part based on customer demand. Takt time takes into account the available hours and the customer demand per day, and therefore fluctuates over time as demand changes. Takt time equals total available production time per day divided by customer demand per day. Consider an EV final assembly line with a daily production target of 500 EVs and an available production time per day of 8 hours, which is 480 minutes. Takt time is calculated by dividing the total available production time per day by customer demand per day. Thus, 480 divided by 500 equals a takt time of 0.96 minutes. Cycle time, which is often confused with takt time, is the total time that a process takes from start to finish. The clock starts the second the work is started and ends when it is a finished part. Cycle time is calculated by adding the individual task times. As part of the overall EV assembly process, let's look at the cycle time for the battery pack assembly station. The typical tasks at the battery pack assembly station would involve lifting and positioning the battery module onto the assembly jig, connecting the high voltage cables, securing the module with bolts, performing quality checks, and moving the completed pack to the next station. The time taken to complete each task is mentioned here. The cycle time is calculated by adding the individual task times, totaling 170 seconds for this particular battery assembly process. Lead time is the total time it takes for a product to be delivered to the customer from the time it is ordered. The clock starts when the order is received and stops when the customer receives the product. Lead time is the cycle time, in addition to the time spent in backlog and time to ship the order. It is calculated by adding up the durations of each task. Now, let us see an example for calculating lead time for the end-to-end manufacturing process for an EV at a dedicated facility. Typical tasks would involve order placement and processing, battery pack manufacturing, vehicle frame and body assembly, powertrain integration, final assembly and quality testing, and finished goods inventory and shipping. The time taken for each step is mentioned here. The lead time adds up to 31 days. Let us now analyze one of the key focuses of Lean, which is to improve process flow. Flow is a term that is used a lot in lean manufacturing. It is an abstract concept that is hard to measure directly. It links all the processes and people involved in a system. Processes flow is the smoothness of materials as they move through a process. Perfect flow means that parts seamlessly move through the system with no disruptions. The flow element of a system is often the most apparent identifier that improvement is needed and is sometimes a reflection of the system's physical design. One-piece flow, or single-piece flow, is a technique used in Lean where a single part is processed, meaning one part is moved through the manufacturing process at a time. One-piece flow helps companies produce the exact part in the exact quantity needed. In summary, lean manufacturing is a continuous process improvement method that reduces waste and non-value added steps, improves process flow, increases overall efficiency, improves product quality and customer satisfaction, and has a number of other benefits. Understanding the importance of differences in time values is important for anyone involved in a lean project or in production. The different time metrics used in lean manufacturing are takt time, cycle time, and lead time. The goals and methods of lean manufacturing are very different from those of traditional methods. Thank you.